Right, so we will be discussing the questions from February-March 2023, the Pure Mathematics 3, Paper 3-2 in this video, right? So we start from question number 1. It is given that x equals to ln 2y minus 3 minus ln y plus 4. They want us to express y in terms of x. Okay, so to express y in terms of x, first of all, I will want to combine all the ln on the right hand side become one term. When I'm having ln 2y minus 3 minus ln y plus 4, I will want to use the formula where when I'm having ln a minus ln b, I can basically combine them become ln a divided by b. Okay, so I'm going to apply this in my right hand side of the equation. Therefore, I'm having x equals to ln, and then I'm having 2y minus 3 divided by y plus 4. Okay, then now I want to bring the ln on the right hand side to left. So when I want to bring it to the left hand side, it is basically log base e, right? Log base e, and I bring the e over, it will become e power x, and the ln disappear on the right hand side. Then I have 2y minus 3 divided by y plus 4. To express y in terms of x, what I need to do is like I have to bring the y to the other side and then multiply the e power x into the y plus 4. After that, I will want to combine all the y at one side. So for me, I will try to group all the y here. Okay, then on the left hand side, I'm having 4e power x plus 3. For the y, I can factorize it out. So from here, you can see that when y is grouped or gather everything on the right, then it will be very easy for you to factorize it out, and after that, you can bring everything over so that you can get the equation where we are having y in terms of x. Okay, so this can be the answer, right? Y in terms of x. So some students, if let's say they try to shift the terms, right, opposite direction with what I show here, then your answer will be negative 4e power x minus 3 divided by e power x minus 2. So basically these two answers are the same. Alright, if you are moving or shifting the terms to the other side, which is the opposite direction with my one, then your answer might look something like this. Okay, so both answers are the same and they are both correct. So this is how we answer question number 1. Question number 2. On an Argand diagram, they wanted to shape the region for the points to represent the complex number z, satisfying the inequality here. There are two inequality. So for the first one, which involved the argument, right? So I will rewrite it again or rephrase it again, become argument, and then z minus 1 plus 2i. And the angle that we want to consider is from pi over 3 and also is greater than negative pi over 3 and smaller equals to pi over 3. Okay, so for this inequality, when I want to sketch it, basically it should look something like this, where I should plot a point at maybe at 1 plus 2i. So a moment here. Okay, so I try to sketch and put in the scale, the ratio for all the x and y axis first. Okay, and then now I will want to plot the point 1 plus 2i. So the point 1 plus 2i on the Argand diagram is 1 and 2 so 1 and 2. This is my point here, 1 plus 2i. And then on the right hand side of 1 plus 2i, okay, I will put a horizontal line so that we can try to measure the angle pi over 3. So for this inequality, they are showing angle pi over 3, where we are going to measure it anti-clockwise from the horizontal line on the right hand side of the point. So when we want to measure up for pi over 3, right? Okay, according to the triangle that we have, the angle pi over 3 means 60 degrees. So if we are having 60 degrees, it means that the height here ratio should be square root 3 over 1. Okay, if let's say I'm having cos pi over 3, it should be 1 over 2, and the opposite length will be square root 3. And now, if you want to draw a triangle, okay, or draw a line on according to the ratio of this triangle, right? What we can refer is, maybe we can refer to have one unit here, and then the point that I want to sketch is maybe square root 3. So square root 3, if you press calculator, you get a value like 1.7 something. That means it will be 1.7 something unit above the 2. So I guess it might be somewhere here. This is 1.7 something. So when I want to draw the line, it will be going up in this direction. Okay, all right. So this is just for reference because if you want to measure or sketch the pi over 3, right, it might not be so easy for us to sketch. So as a reference, you can take the ratio for the triangle as a reference. So if let's say from 1 until 2 is 1 unit, right? So the vertical one should be square root 3 unit. So square root 3 unit means 1.7 something. So you measure 1.7 something above the 2 and you plot a point there. Therefore, this will be a line that represents the pi over 3, angle pi over 3. So same thing happen. For angle negative pi over 3, you need to measure it in clockwise direction. So for clockwise direction, I want to get negative pi over 3. And again, to measure negative pi over 3, you take 2, then measure square root 3 unit below the 2. So square root 3 unit, that means 2 minus 1.7 something, you'll get 0.3 maybe. Alright, something like that, or 0.2 something. Okay, so you roughly plot the point here at 0.2 something or what, then you try to sketch the line passing the point. Okay, and this angle basically is also pi over 3. Alright, and according to our inequality, it is negative because we are measuring it in the direction which is clockwise direction from the horizontal line. So this is how we sketch the two lines here for this inequality that involve the argument. And after that, we need to sketch real z smaller equals to 3. So what's the meaning for real z smaller equals to 3? The real part of z basically means the x. It also means that I'm having the line x smaller equals to 3. If I want to sketch the point or sketch the line for x smaller equals to 3, at first I need to sketch x equals to 3 first. So for x equals to 3, right, it is a vertical line that passes through the 3. Pass through x equals to 3. Okay, so this is a vertical line that we have. So maybe I draw it again. Right, so this is a vertical line that I have. Assume that this is a vertical line, okay? And after that, we need to try to shade the region. Okay, so to shade the region, what we need to do is the angle for the argument one, it is negative pi over 3 until positive pi over 3. That means it is within this area, the two lines. And when we are having x smaller equals to 3, that means I'm having the left hand side, I'm considering the left hand side of the vertical line. If let's say I'm trying to shade the whole area here and also the area on the left hand side of the vertical line, the overlapping part basically is this part. Okay, so this is the region or the shaded area that fulfill the two inequality that we draw in the Argand diagram. Okay, and this is the answer for part A that we have. Alright, let us proceed to part B. For part B, they are asking calculate the least value of z, argument z, for points in the region from A. Give your answer in radians, correct to 3 decimal places. Okay, so first of all, we need to decide where is the least value of argument z. Right, so if you try to have a look for the diagram here, the least value of argument z, we need to make sure that we try to shift it from 0, 0. Okay, we want to measure the angle from 0, 0 until the point z. Z can be any point in the shaded region. If let's say my z is at the higher point, as example here, okay, so you can see that your argument is actually quite large. They are asking for the least, that means the smallest value for argument z. So if I'm looking for the smallest value for argument z, what will I have is I will try to sketch my z in the area, in the shaded area to the lowest point. So the lowest point of z in the area should be this one. Okay, so this is the value of z, and you can see that it is basically in the fourth quadrant, right? Then the angle that I want to measure, or the argument that I want to measure, is from the point to the z here, so that we can measure the argument. Okay, so please take note that my diagram is not to scale. So if let's say in exam, if it is possible, try to draw your diagram as nice as possible, at least as accurate as possible, so that you can look at the diagram very clearly to decide the value of argument and also modular z that they want you to find. Okay, then let's continue. I already know that this is the point z, where I will have the smallest argument at this point. Okay, so to get the value for argument, there are a few ways that we can use to solve this question. First, either you try to find out the coordinate geometry, or the coordinates for this point z, or the complex number for this point z, then you can get the argument. Another option is you can try to use the triangle here. Okay, so this triangle, to get the ratio or the value of z also. From there, then you can also get the argument. So for me myself, I'm going to show you how to find out the coordinate for z by finding out the equations. Okay, so I will label this point. For the point z, I know that the green color here is point z. So from what I observe, I can see that it is actually the intersection point between this line, okay, between this linear line and also x equals to 3, the line x equals to 3. Okay, so basically z is the intersection for these two lines. Alright, so the first line here is very direct, where I'm having x equals to 3. And then for the other line here, I want to form the equation of this linear line. To form the equation of this linear line, maybe I will write out here. Right. To form the equation of this linear line, I know that the gradient basically is equals to tangent theta. So gradient is equals to tangent, and the angle is actually negative pi over 3, right? When we measure it in clockwise direction, therefore the tangent will be negative pi over 3 for gradient, right? So for this case, the gradient that we get will be equals to negative square root 3. Okay, and what is the passing point? This is the passing point basically. This is the passing point for this linear line, and the coordinate for the passing point is 1, 2. To form the equation of the line, you can use the equation where y minus y1, the passing point is, for the y coordinate is 2 lah, 1 and 2 right? So y minus y1 equals to m. M is square root, negative square root 3, and then x minus x1. So x minus 1. And from here, if I try to simplify my equation, the linear equation that I have will look something like this. Okay? And after that, this is my linear equation. So I'm having the equation line number 1. And since it is the intersection point, the z is intersection point with x equals to 3, right? So x equals to 3 will be my second equation. So to find the intersection point, I can solve the equation simultaneously. So to solve the equation simultaneously, I substitute equation number 1 or number 2 into equation number 1. And therefore, I'm having 1 equals to negative 3 square root 3 plus square root 3 plus 2. And my y coordinate will be 2 minus 2 square root 3. Okay, so from here, right, we already know that our z, complex number z, is actually having the value x plus yi. So x is a 3, then your y is 2 minus 2 square root 3, and then I. This is the coordinate, or maybe the complex number of z. where it is the intersection point shown in the diagram. And now I'm going to get the argument of the z. To get the argument of z, because this z is in the fourth quadrant, right? Okay, so this z is in the fourth quadrant. Therefore, when I want to take the argument, the formula will be negative, okay, negative tangent inverse the basic angle. So the basic angle, I have to make sure that the magnitude is a positive magnitude. Alright, so I'm taking y divided by x. Okay, so some students will ask, my original y coordinate is 2 and negative 2 square root 3. But why I change it become 2 square root 3 minus 2? Okay, so the reason is because when I want to get the argument z, I want to get the basic angle, and this value inside must be a positive value. If I try to use calculator and press 2 minus 2 square root 3, right, I get a negative value actually. Therefore, I have to shift it or change it become positive value, where it should be 2 square root 3 minus 2. And it will be a positive value. And 3 originally is positive value, right? So you cannot do any adjustment on this value. So I just want to ensure that the whole bracket, the value inside the bracket here is a positive value, so that I can get a basic angle. Then I will press calculator for tangent inverse 2 square root 3 minus 2 divided by 3. The value that I get correct to 3 significant figure will be 0.454. Okay, so this is how we actually get the answer for the smallest argument of z in the shaded area that we have. Okay, so there's another suggestion for the solution for part B. If let's say you don't want to form the equation for the line, right, and solve them simultaneously, another alternative method is you can try to use the ratio of the triangle, okay, to find out the coordinate of z. So again, this is the coordinate of z that we know. It has the smallest or the least value of argument, right? And I want to know this particular the coordinate for this particular point. Okay, so for this particular point, I already know that the x coordinate is 3, and I want to know what's the y coordinate for this point. To get the y coordinate for this point, basically you can try to use the ratio of the triangle also. So I try to sketch the triangle out, okay, where it should be this one. This is the triangle that we are going to focus on, this one, this triangle. Okay, so if you try to observe the triangle, I draw it out here. Okay, and then the angle here is pi over 3, right? And if you try to observe, this horizontal line is actually having 2 units. Okay, from 1 until 3, it is having 2 units here. And for tangent, for pi over 3, okay, what is the ratio for tangent pi over 3? So the ratio for tangent pi over 3, by right should be square root 3. Okay, so that means the opposite divide by the adjacent length, it should be equal to square root 3. And now my adjacent length is 2. So I want to know what is the length for this one. Therefore, I'm having question mark divided by 2 equals to square root 3. And therefore, the question mark here should be 2 square root 3. Which means that the length for this vertical line should be 2 square root 3. Okay, so I'm using the ratio of tangent pi over 3 should be equals to square root 3. Then from here I get the length, okay, for this particular triangle, the height for this particular triangle. Okay, so after I get the height for this particular triangle, right, since I know that this is the z, I want to know the coordinate for this z, the y coordinate. Okay, so what can I do is I try to observe from the diagram again. I know that this horizontal line is having 2, right? You can see 2. The y coordinate for this height here, this point here is 2. And then z is 2 over 3 unit below the 2. That means the y coordinate for the z will be 2 minus the height of the triangle, 2 minus 2 square root 3. Therefore, from here you know that z can be equals to 3 plus 2 minus 2 square root 3 then I. Alright, so I'm trying to use the ratio of the triangle here. Then I take the original y coordinate at this point, y equals to 2. Okay, then I minus 2 square root 3 unit, and I will get the y coordinate for z. Alright, so this is a y coordinate for z. Then my z is having the complex number 3 plus bracket 2 minus 2 square root 3i. Okay, then from here I can calculate, or I can get the argument of z. So to get the argument of z again, if you observe it in the diagram, you realize that it is a fourth quadrant. So for fourth quadrant, you need to change all the value here become positive so that you can get the argument. So I'm using negative tangent inverse 2 square root 3 minus 2 divided by 3. And therefore the answer is still the same like what we showed earlier, which is negative 0.454, correct to 3 decimal places. According to the question, okay, they're asking for the answer correct to 3 decimal places. So this is another way for us to find out the coordinate for z. Either we can form the equations to solve it simultaneously, or either we can use the triangle, the ratio of the triangle, where you must know that tangent pi over 3 is equal to square root 3, find the y coordinate of z, and then try to find the argument of z according to the quadrant that it is located. Okay, so this is how basically we answer question number 2. Question number 3, we are given a polynomial. Okay, so as shown here, and then it's denoted by px. So when px is divided by this quadratic divisor, okay, the remainder is 3x plus 2. They want us to find the values of a and b. Okay, so for this question, basically I will want to use the general polynomial equation, where a polynomial equation can be written as divisor multiply with quotient and then plus remainder. Okay, so generally I'm going to use this equation to get the value for a and also b. Okay, so I will start writing out the steps here. My polynomial should be 2x power 4 plus ax power 3 plus bx minus 1. And then equals to, the divisor is given in the question where it is x squared minus x plus 1. So I'm having x squared minus x plus 1. And now I need to write in the quotient qx. Okay, so to write in the quotient, first step is you need to think what is the first terms to start with. So to decide the first term to start with, basically we can decide it ourselves by using x squared, the first term of the divisor, multiply with the something, okay, to get 2x power 4. So you have to think the something here, alright, so that the term here multiply with x squared, I'll get 2x power 4. So when I decide, okay, when we have a look and decide, right, it should be actually 2x squared. So that 2x squared multiply with x squared, then I get 2x power 4. So this is the first term for the quotient, okay, for this question, right? After I decide the first term for the quotient already, then the next term will be 1 degree lower for the first term. So now for the quotient, you are having x squared at first, right? So the next term will be 1 power lower, which is x power 1. And then the coefficient of x power 1, because we don't know, so we'll denote it maybe by using a, capital letter A. Right? So ax power 1, and then continue until we get a constant. So ax power 1, we reduce the power again by 1, so we are having a constant term, which is a b. And this is actually our quotient for this question. Then plus remainder. The remainder is given actually, which is 3x plus 2. So plus rx will be remainder 3x plus 2. Okay, so once I write out the equation already, now what I want to do is that I want to expand the equation, and after that I group the terms in x squared, x power 4, and so on, and we compare the coefficient. So from there we will slowly get all the unknown that we want to know here, the small letter a, small letter b, capital letter A, and also capital letter B. Okay, so I expand everything. For the left hand side, I can't do anything, I will just copy it. For the right hand side, I try to expand everything. So expand it term by term. I will have 2x power 4 plus ax cubed plus bx squared, and then negative 2x power 3 minus ax squared then minus bx. And further expand it for the last one, I'm having 2x squared plus ax plus b. And then copy the remainder at the back. So now after I expand it, I'll get a very long equation on the right hand side. What I want to do now is I try to group all the term with the same power of x together. As an example, I'm having 2x power 4. Okay, I have only one term of 2x power 4. Next one, I want to group all the x power 3 together. Last time I'm having ax power 3, negative 2x power 3. So I think we are having two terms here, right? So when I group them together, I'm having a minus 2 and then x power 3. So how about the next term? So the next term will be x squared. Okay, so we are having bx squared minus ax squared, then plus 2. So if I group them together, I'm having b minus a, then plus 2 with x squared. Okay, continue further. I'm looking for x power 1. I'm having negative bx plus ax plus 3x. So if I group them together again, I'm having a minus b, then plus 3 with x. And lastly, we are going to group all the constant term together. So for the constant term here, I can see we are having a b and also a 2. So we are having b plus 2. Okay, so from now, we are going to compare the left hand side and the right hand side slowly so that we can get the value for all the a, b, capital letter A, B, and small letter a, b eventually, right? Okay, so maybe for me, I will start with the constant term first. B plus 2, I will compare it with the negative 1 on the left because you can see that both of them are actually the constant term. Right, so if you try to compare it, I'm having b plus 2 equals to negative 1, and very easily we'll get the value for capital letter B, which is negative 3. Okay, and after that we try to analyze and observe and see which is the second term that we can try to compare. Okay, so maybe I can try to compare the coefficient for x squared. So for the right hand side, I'm having b minus a plus 2x squared, but on the left you can see that we are not having any term about x squared, right? So when you're not having any term about the x squared, that means the coefficient is equals to 0. I'm having 0x squared, that means. So if I want to compare it, I'm having b minus a plus 2 will be equals to 0. Okay, since I know already the value for b is negative 3 just now, so I'm having negative 3 minus a plus 2 equals to 0. So from here, I'll get the value for capital letter A, which is negative 1. Okay, then next, what else can I find out? Okay, what else can I compare so that I can get the next value further? Okay, so from here, I think you can straight away compare a minus 2x power 3 with ax power 3. So the small letter a will be equals to a minus 2, where you already get the value for capital letter A is negative 1. So minus 2, therefore your small letter a is negative 3. Cool. So this is actually the value for a equals to negative 3. And then the last one that we want to compare will be the a plus b, a minus b plus 3x. Okay, so I compare with the b. So from here you can see that small letter b, I can get it by using capital letter A minus capital letter B plus 3. And what is the value that I will have? Negative 1 minus negative 3, then plus 3. And the b that I get will be actually equals to 5. And from here you can see we already get the answer for small letter a and b, where a equals to negative 3 and also b equals to 5. Okay, so this is how we answer question number 3. Okay, so we need to solve question number 4 now. Okay, solve the equation for this one. This equation shown. Give your answer in the form of x plus yi, where x and y are real. Alright, so for this question, we should know that it is actually the complex number question, and then we are having z and z conjugate in the equation. Okay, so for information, right, for our to recall, basically z is a complex number, and pattern will be x plus yi. And then when you are asking for z conjugate, generally it should be x minus yi as well. Right, so this is something that we need to know before we can start the solution. Okay, so first of all, if I observe the question here, I'm having fraction as a first term. There's a fraction here. So maybe what I want to do is that I will want to rationalize it first. Okay, so I try to rationalize the first fraction here, where the denominator is 1 plus 2i. To rationalize it, I need to multiply it with 1 minus 2i, top and bottom. Okay, then minus z conjugate plus 30 plus 10i, then equals to 0. Okay, so when I try to rationalize it, the denominator I'm having 1 plus 2i minus 2i and also negative 4i squared. Negative 4i squared will become plus 4 because I squared is negative 1. Okay, then for the number on top, I just copy it out. I don't want to expand it yet. Okay, then minus z conjugate plus 30 plus 10i equals to 0. So from here, if you try to observe the first term, I'm having 5 on top, can simplify with the 1 plus 4 at the denominator. Okay, and now if you observe the equation, my solution now, I'm having the z and z conjugate already. So to solve this equation, I will substitute z equals to x plus yi, z conjugate equals to x minus yi into the equation and to solve it further. Okay, so z is x plus yi, 1 minus 2i, then z and z conjugate is this one, plus 30 plus 10i equals to 0. And now we will want to expand everything here. I'm having x minus 2xi, then plus yi. I'm having negative 2yi squared. So negative 2yi squared will become positive 2y. Okay, then minus, for this part I'm having x squared. Okay, and also negative y squared I squared. Negative y squared I squared, I will have positive y squared. Then plus 30 plus 10i equals to 0. Okay, then again, continue further. Maybe now what I want to do is that I try to group all the real number together and also all the imaginary part together. So let me expand it first. Okay, so if I try to group all the real part together, I'm having x, 2y, minus x squared, minus y squared, plus 30. Okay, so if I rewrite it, I'm having x plus 2y, then minus x squared, minus y squared, plus 30. This is all my real part without the I. And then for the term with I, I'm having negative 2xi plus yi and also the 10i here. So if I try to group them together, I'm having y minus 2x plus 10 and then I, and it is equals to 0. Okay, so I compare the left hand side with the right hand side of the equation. My right hand side is having 0 which means that if I want to compare the left hand side, the real part will be x plus 2y minus x squared minus y squared plus 30 equals to 0, and this will be my first equation. The second equation, I'm taking the imaginary part, y minus 2x plus 10 equals to 0, and this will give me the equation where y equals to 2x minus 10, and I will treat this as a second equation. And I think the idea here is very clear because if you have a look, we are having two unknown x and y, and then we are having two equations here. So to get the value for x and y, we need to solve the equation simultaneously and to get the answer. Okay, so I will substitute equation number 2 into equation number 1. Okay, so when I want to sub equation number 2 into equation number 1, I'm having x plus 2 times of 2x minus 10 minus x squared minus y squared. So 2x minus 10 and then square plus 30 equals to 0. Continue, expand everything. 4x squared minus 20 times 2, 40x plus 100, then plus 30 equals to 0. Okay, so you can see that we already reduced my equation into one variable, which is the x. Okay, then of course we will need to try to group them very carefully. I'm having x plus 4x, then plus 40x. Okay, so x plus 4x plus 40x, and I'm having 45x. Okay, negative 20 minus 100 plus 30. Okay, so negative 20 plus 100 negative 20 minus 100 plus 30, I'm having negative 120 plus 30. So negative 120 plus 30, I'm having negative 90. Then for the term with x squared, I'm having negative x squared, negative 4x squared. So negative x squared and negative 4x squared will give me negative 5x squared here. It is equals to 0. And we get a quadratic equation in terms of x. So to solve it, maybe I will differentiate the whole equation by using negative 5. Okay, I simplify first by using negative 5. And eventually I'm getting x squared minus 9 times 5, 45. So 9x, then plus 18 equals to 0. Okay, then let us solve it. Okay, we can factorize it and become x minus 6 and also x minus 3 equals to 0. And the value of x that I get is x equals to 6 and also x equals to 3. Substitute the value x equals to 6 and also x equals to 3 into the second equation to get the value for y. So 6 times 2, 12 minus 10. Your value of y for this question will be 2. Okay, and then substitute x equals to 3 here, then your value for y will be negative 4. Okay, so after we get the value for x and y already, then please write your final answer of z in a complex number form. So z can be two values. It can be either 6 plus 2i or it can be 3 minus 4i. Okay, so we are actually having two values or two answers for the complex number z. Okay, so this is how we solve question number 4. Okay, so now we are at question number 5. We are given parametric equations of a curve and as shown like this. They want us to show that dy dx equals to e power negative 2t. Okay, so to get the dy dx from parametric equations, basically we need to differentiate the equation separately, where I will start from the x first. When I'm having the equation x equals to t multiplied with e power 2t. Okay, so from here you can see that it is actually a product of two functions. We are having the first bracket which is t, the second bracket which is e power 2t. Therefore, to differentiate this equation, we have to apply product rule. Okay, so I'm going to differentiate x with respect to t. Okay, so for product rule, I will do it in this way. First bracket is t, second bracket is e power 2t. So what I'm doing is, I will maybe I will copy the first bracket first, then differentiate the second bracket. So differentiate second bracket, e power 2t, I will have 2e power 2t. This is differentiate copy the first bracket, differentiate the second, and now I want to differentiate the first bracket, differentiate t, I get a 1, and I copy the second bracket. So basically this is what we have for the product rule. Okay, then if I try to simplify it, what am I having here is I can factorize out e power 2t, and my equation looks something like this. This is for the x, And now let's continue with the differentiation for y with respect to t. I'm having y equals to t squared plus t plus 3. And now differentiate the equation with respect to t. I'm having 2t plus 1. Okay, to get the dy dx, I need to apply chain rule where dy dx can be written as dy over dt and then multiply with dt over dx. What is dy over dt? So we are having the equation here. Dy over dt can be written as 2t plus 1. And then for dt over dx, I need to make this function or make this equation reciprocal. So 1 over, I'm having 1 over e power 2t and then multiply with 2t plus 1. And from here, I think we can see very clearly that the 2t plus 1 can be simplified. And I left only 1 over e power 2t. So 1 over e power 2t, I can rewrite it become e power negative 2t. Okay, so this is how we show the value, how we show the expression for dy dx. And proceed to part number B. For part number B, they want to show that the normal to the curve where t equals to negative 1 will pass through this particular point. So when t equals to negative 1, I need to find out the equation of normal to the curve first. Okay, so before we can find out the normal to the curve, we need to find a few important values first. First of all, we need to find out when t equals to 1, what is the value for x. Okay, so from the question itself, we are having that x equals to t e power 2t, right? If I substitute negative 1 into this equation, then I will have negative e power negative 2. This is my coordinate for the x. And I also need to find out the coordinate for the y when t equals to 1. My y equation is t squared plus t plus 3. And if I substitute negative 1 into the t here, and simplify it, I will get my y coordinate, which is equals to 3. This is the x and y coordinate when t equals to 1. Besides the passing point or the coordinate for x and y that pass through the normal or the tangent, I also need to know what is the gradient of the tangent, okay, when t equals to negative 1. So y dy over dx, our equation just now is e negative 2t. If I substitute negative 1 into the equation here, I'm having e power 2. And please take note that this is basically the gradient of tangent. Okay, so once we already get all the information needed, right, I can use all the information here to form the equation of normal. So before I find the equation of normal, I need to know what is the gradient of normal. Since we know that the normal and tangent are perpendicular to each other, and we should know and remember that when we are having the gradient of normal, multiply with the gradient of tangent, it should be equals to negative 1. My gradient of normal, I need to find it out now, and then the gradient of tangent is e power 2, and it is equals to negative 1, and therefore I get my gradient of normal is equals to negative 1 over e power 2, and again I can rewrite it become negative e power negative 2. And this is the gradient of normal. Gradient of normal, right? Okay, I have the gradient of normal. I have the passing point that pass through the normal as well. Therefore, I can form the equation of normal. Okay, so what is the equation of normal here? I'm using the general formula y minus y1, that means y minus y coordinate equals to 3, equals to gradient mx plus mx minus x. So m is negative e power negative 2, then x minus x coordinate, where it will become plus e negative 2. The x coordinate is here, right? So x minus negative e power negative 2, I'll get positive e power negative 2. And after that, I try to rephrase and simplify my value or my equation here. I will have negative x over e power 2 Then the e power negative 2 multiplied with e power negative 2, you add the power together where you are having e power negative 4. And then for the negative 3 here, if I want to move it to the other side, I'm having a plus 3. So this is how our equation of normal looks like. Okay, then for this question, they're asking us to prove that the normal line will pass through the point, will pass through this point. So if you try to observe this point, right, you can see that the coordinate for x is equals to 0, then this is the value for the y coordinate. So what am I going to do is I'm trying to substitute. I will let x equals to 0, and I want to know what is the coordinate for y. Okay, if I let x equals to 0, then the equation will become y equals to negative e power negative 4 plus 3. And it can be written as 3 minus 1 over e power 4. If you double check with the coordinate of y that they show us in the question, it is the same. Okay, therefore it proves that this point will actually pass through the normal of the curve, or the normal of the curve will pass through this point. Alright, so this is how we solve question number 5 for this paper. Okay, so question number 6, they want us to express this phrase or expression into the form of r cos theta minus alpha. R should be a positive value, and also the alpha should be in the first quadrant from 0 until pi over 2. Okay, so for this question, right, generally we are having the formula, okay, for the r and also the alpha. After we expand everything and compare them, the general formula for r is actually square root of a squared plus b squared, where the a and b are actually the coefficient in front of cos and sine. And for the alpha, it should be tangent inverse b over a. Okay, but please still note that when you want to apply these two formulas straight away, right, you have to know that what kind of equation we are going to change, or the expression that we are going to change. For this question, they want us to change it become r cos theta, and therefore when we are having our original expression, right, we have to ensure that the cos theta is actually in front of the expression. So for this expression, I need to rephrase it first so that it is 12 cos theta, then plus 5 sine theta, and it is equals to r cos theta minus alpha. I want to ensure that when I want to change the expression become cos, and the first term in front of the expression should be a cos also, so that this is basically the a and this is the b. Alright, so these are small details that we all must be aware of before we can apply the formula directly to find out the value for r and also alpha. Okay, alright, so this generally we already put the cos theta in front. So from here, I think we can see very clearly that the a is 12 and the b is 5. Okay, so let us start the calculation straight away. To get the value for r, it is actually a squared plus b squared. So a squared will be 12 squared plus 5 squared. And if you try to simplify, you have square root 169. And this is equals to 13. Square root 169 is 13. To get the value for alpha, I'm taking tangent inverse b over a. To get the tangent inverse b over a, it should be b, which is a 5, and then a should be a 12. So tangent inverse 5 over 12 into radian, it should be 0.395, correct to 3 significant figure. Therefore, the equation that we want us to show is 12 cos theta plus 5 sin theta, and it is equals to r, which is 13, and then cos theta minus alpha, so 0.395. Alright, so this is basically the expression that we can change our original 12 cos theta and 5 sin theta become this one. Okay, so again, a reminder, since the question wants us to rephrase it become cos theta minus alpha, you have to ensure that to apply the formula given here, as shown on the right hand side here, please make sure you arrange the cos theta in front, and also so to make sure that it follows like the cos here. And then there's another small thing to check is when you're having cos, the sign in the middle and also the sign inside are always opposite. Okay, so to apply this particular formula again, please make sure that your equation or expression fulfill the small rules here. Cos theta must be in front to change it become cos. Okay, so this is what we have for part number A. And now let us continue to part B. Okay, so for part B, they want you to solve the equation 5 sine 2x plus 12 cos 2x equals to 6. From part number A just now, we can change the 12 cos theta plus 5 sine theta become this equation. And for part number B, you realize that theta become 2x, right? So you can change the theta become 2x, theta become 2x, and also this theta will become 2x as well. But the remaining values and everything are still the same. Okay, so if I try to rewrite our equation here, this part of the equation, I will replace it by using the result that I showed in part number 8, where I will get 13 and then cos. Theta become 2x and then minus 0.395 and it is equals to 6. Alright, then for the range or the domain that the question wants us to find out the range of x, the x is between 0 until pi. Therefore, when I want to find out the angle for 2x, in general, you should at least go through for four quadrants or one cycle, right? So let us start the step here. Okay, first of all, I will want to bring the 13 over and I will get this. And now I want to get my basic angle. Okay, to get the basic angle, I will take cos inverse, then 6 over 13. If I try to get the basic angle, right, I will get the long value. I will keep it as long as possible first. So 1.091667 and then 689. Okay, so this is my basic angle. Then now I want to go through the quadrants so that I can find out the answer for 2x minus 0.395. Okay, so to go through for the quadrant, right, these are the general formula that we should have for the angle that we can find out using different quadrants. Okay, so I'm having all positive in the first quadrant, sine positive in the second quadrant, tangent positive in the third quadrant, and cos positive in the fourth quadrant. For this question, I'm having cos, and this value is a positive value. Therefore, I'm going to look for the quadrant with positive cos. So in the first quadrant, everything is positive, right? That means I want to take the answer from the first quadrant. To take the answer from the first quadrant, the value is basic angle. Therefore, I will put the basic angle in my first quadrant answer. And then I go to the second quadrant. Cos is negative in the second quadrant, therefore I don't want to answer from this part. Third quadrant, cos is negative. I also don't want to answer from this part. And the fourth quadrant, cos is positive, therefore I want to answer from this quadrant. To get the answer from this quadrant, you need to take 2 pi, then minus the basic angle that you found out just now. So I will take 2 pi minus 1.09167,689. And then from that, I will get the long value. Alright, so we can take 2 pi, then minus 1.091,067,689. Okay, so this shows that I'm getting the answer from the fourth quadrant. And after that, to get the value for x, right, for every single value here, what we need to do is I remove the 0.395 over become plus, and then for every answer here, I divide it by 2. If we try to simplify this answer, right, basically what do I get is I will have 0.743 and also 2.79, correct, to 3 significant figure. Okay, so this is the final answer where I already plus 0.395 to every single answer on the right and also divided by 2 after I add the 0.395. Okay, so if you didn't do any careless mistake, by right, this is the correct answer. Okay, so this is how we solve question number 6. Question number 7. Okay, we have a diagram, and then the diagram shows a circle with the center O and radius R. The angle of the minor sector AOB of the circle is x radian of this one, the angle, alright? If you know that the minor sector is x radian, the angle, the minor sector, we should know that the large sector here, the angle should be 2 pi minus the x. Okay, then they are the area of the major sector. So they are talking about the major sector now. The area is the 3 times the area of the shaded region. So 3 times of the shaded region. So first part, they want us to show that x can be written as this equation. Okay, so how can I start the question so that I can get the equation that they want us to prove? Right, and basically we need to look for the information given in the question. So what can I see here is they are giving this one. The area of the major sector is 3 times the area of the shaded region. Okay, we'll start from this information. So area of major sector is equals to 3 times the area of the shaded region. Okay, how to form the equation for area of the major sector? So the area for sector is half r squared theta. I'm having half r squared is the radius square. So in our question here, the radius is still the r, right? So I'm having r squared. Then theta, theta means the angle. For the major sector, the angle is 2 pi minus 3, 2 pi minus x. Therefore, I put it as 2 pi minus x equals to 3 times the area of the shaded region. To get the area of the shaded region, you can see that it is like a segment. Okay, I can take the area of the minor sector. This is the area of the minor sector, then minus a triangle. Then I can get the area of the shaded region, right? Okay, so area of the minor sector will be half r squared theta. Then in this case, it is the x basically. Then minus the area of this triangle. To get the area for this triangle, I will use half r times r and then sine x. Okay, so half r squared sine x. Okay, if I look at this equation, we can observe for all the terms here from the left and right hand side, all of them are having half r squared. I can simplify off the half r squared for the whole equation. And then if I rephrase it again, I'm having 2 pi minus x equals to 3x minus 3 sine x. Okay, then now I will slowly rephrase my equation so that I can get the equation that they want us to prove in the part A. I will group all the x together, then I'm having 4x here. So 4x minus 3 sine x. And then I think it's quite obvious if I try to group 4x on one side, then other terms on the right, then I will get very easily x equals to 3 over 4 sine x, and then plus 2 over 4, 2 pi over 4. So we simplify 2 pi over 4, you get 1 over 2 pi. Okay, so this is how we prove it. But of course, when we want to start, we have to use the information given in the question to start with. Then let us proceed to part number 2. For part B, they want us to show by calculation that the root of this equation in A lies between 2 and 2.5. For this question, there are many ways for us to prove it. Then for me, I'm going to use the sign change method. For sign change method, our original equation is this one. And what I need to do is I will rephrase it become function f. So I will put it as function fx and I move all the terms to one side. I will move the x to the other side and it will become negative x. Okay, then after that, to get the sign change, I will substitute value 2 into my equation. So half pi plus 3 over 4 sine 2 minus 2. And the answer that I get is a value where it is a positive value like 0.253. And if I try to substitute the 2.5 into my function, I realize that the value that I get will be a negative value where it should be equal to 0.480. Okay, and please take note that if you want to use the calculator to help you to get the value here, since we are having the sine x, the trigo, okay, in our expression, therefore our calculator should change to radian mode first. So please make sure you put your calculator into the radian mode so that you can get the value as shown in this question, in this solution here. Right, so from here you can see very clearly that we are having the sign change. One value is positive, one value is negative. When you substitute 2 and 2.5, this means that the range, the roots lies between 2 and 2.5. So I will make a simple conclusion for these steps. Sign change can be seen. Okay, at f2 and also f2.5. So we can say that the root actually lies between 2 and 2.5. Okay, and this is how we solve question number B. And let's proceed to question number C. For question number C, they want us to use an iterative formula based on the equation A to calculate the root correct to 2 decimal places and give the result of each iteration correct to 4 decimal places. Okay, so let me rewrite our iterative formula again. So the iterative formula in part A should be x equals to half pi, then plus 3 over 4 sine x. This is my iteration formula, and I'm going to use it. Okay, so I need to have an initial value to start with. Okay, so what is the initial value that I can use? For this question, it didn't fix any initial value. For us, right, we always can use the sign change method, the question in part B to help us or to give us a hint, to start with. So since they tell us that the roots lie between 2 and 2.5, you can use any value that's close to 2 or 2.5 or any value within them. Alright, you can use 2, no problem. You can use 2.5. You can also even using 2.2, 2.3 to start and so on. Alright, some students, they might see that where's the midpoint of these two values, the sign change value here, and then they are taking a value which is closer to 0. So there are many ways that you can decide. But this is a reference for you. Okay, what is the initial value that you can take so that you can get to the root in a faster way. For me here, I'm going to use x equals to 2.0. Okay, and if I want to get x2, how can I get the next value, x2? So basically to get x2, I'm going to substitute it into my iteration formula where it is half pi, then plus 3 over 4, and then sine 2. Okay, then we are going to press calculator to get the value for us. Okay, so first we need to key in the formula first. We should have half pi and then 3 over 4 sine 2. Since the question here, our iteration formula is having sine x, which is in terms of trigo, I will want to change my calculator into a radian mode first. So radian mode should be 4. So I make sure that I change it become the radian mode, and now I will key in the formula. So for the formula, I'm having pi over 2, where I will take pi divided by 2. It is pi over 2, right? Then plus 3 sine 2 divided by 4. So I'm having 3. Then sine 2 means sine x, because this value of x will change from iteration to iteration. So 3 sine x divided by 4. And this is my equation here. Okay, for the calculator. If you want, you can put it in the fraction form, no problem. Right, so after you key in the formula, make sure you key in it correctly. Okay, then we'll start to insert the value. Okay, so first please click calculate, and then they're asking you what is the value of x that you want to put in. So our very first value here is actually 2. So I will 2. I'll key in the 2 and also press the equal sign. Then for the value here, I'm getting 2.252769397. It's a long value, right? According to the instruction of the question, they want us to have our iteration correct to 4 decimal places. So what I'm going to do is I will write my answer into 4 decimal places, where it should be 2.2528. So I put in 2.2528. After I get the x2, the value for x2, I want to continue for the value of x3. I will repeat the step here. Press calculate and then key in the value 2.2528 and press equal sign again. Then I get my next value, which is 2.1530. So I will put in 2.1530. Okay, I will continue my iteration until I get 2 decimal places answer which is repeated. Okay, so I will continue again. Press calculate, repeat the same process, 2.1530, then press equal sign, 2.1972. Again, 2.1972. Okay, so the answer for 2 decimal places haven't repeated yet, right? So we will just continue again and again. Calculate again, 2.1972. Press equal sign, then I get 2.1784. 2.1784, and then go to x6. These two values for 2 decimal places still haven't repeated yet, so just continue again. So calculate again, 2.1786, 84, equal sign, 2.1866, so 2.1866, x5, 2 decimal places, answer is 2.18, x6 is 2.19, haven't repeated yet, so I continue again, so x7. All right, then repeat, calculate, 2.1866 equal sign, 2.1830, 2.1830, haven't repeated yet, so continue again. Okay, calculate, 2.1830, press equal sign. So I'm having 2.1846. So 2.1846. If you try to observe these two values here, x7 and x8, both of them are basically 2.18 for 2 decimal places answer. If you want it to be safe, then you can continue for one more iteration. So calculate again, then 2.1846. Press equal sign. So 1839, 2.1839. For the consecutive three value here, right, when you try to investigate the value for 2 decimal places, you will see that they are equals to 2.18. Alright, so I think it is enough for us to conclude that the root for this question is basically 2.18. Correct to 2 decimal places according to the instruction of the question. Okay, so for this question, if you can see that my iteration is quite long, basically from x1 until x9, because the value that I start with is 2.0. If let's say we are starting the initial value, which is very close to the roots, then we are having shorter list of iterations to get the root. Okay, so the initial value basically will decide how long your iteration will have. Alright, if your initial value is very close to the iteration, to the roots, basically your iteration will be much more shorter. Alright, so this is how we solve question number 7. Okay, so we are at question number 8. There's a diagram here, and the diagram shows the curve y equals to x power 3 log x for x greater than 0, and the minimum point is m. They want us to find the exact coordinate of m. Right, so since m is a minimum point, so when you see the keyword minimum point, we have to find out dy dx, and we let it equals to 0. And from there, we will try to solve for the coordinate of x and y. Okay, so let's have a look for the equation here. Since we are having y equals to x power 3 log x, and you can see that basically it is the product of two functions, where the first function is x power 3, and the second function is log x. Okay, so when you're having the product of two different functions here, we will need to use product rule when we want to find out the differentiation. Okay, so for the product rule, for me, I'm going to denote the first function as first bracket, then the second function as second bracket. So to get the dy dx, basically it's like this. We have to differentiate the first bracket. So differentiate x power 3, we have 3x squared. Copy the second bracket. Differentiate the first, copy the second, and then plus. Now we do it the other way around. We copy the first bracket and differentiate the second. So differentiate log x, basically I'm having 1 over x. Alright, and after that I'm having 3x squared log x and then plus x squared. Okay, so to get the minimum point, we actually need to let dy dx equals to 0. And we try to solve it. So if I try to factorize out the x squared, I'm having 3 ln x plus 1. Okay, and from here we try to solve it. I'm having x squared equals to 0, and then 3 ln x plus 1 equals to 0. Okay, so for this part, if you try to solve it, right, the point that you get is this one. By right should be this one. Okay, and it is not related to m. Our m should be somewhere at this place. So I'm going to solve this 3 ln x plus 1 equals to 0. Okay, when I try to solve it, I bring all the number to the other side. The ln, if I bring it over, it will become e, because ln is log base e. So I'm having e power negative 1 over 3. This is the x coordinate for the m. And now we need to find out the y coordinate for the m. What I need to do is substitute it into the equation. So e negative 1 power negative 1 over 3, 3. X power 3, right? So x power 3. And I'm having ln e. X is e power negative 1 over 3. Right? And then for the power here, power outside another power, right? We have to simplify by multiplying them. So multiply this whole time, I'm having e power negative 1. Okay, and then for this part, when I'm having ln e power negative 1 over 3, I can pull the 1 over 3 in front so that it become a number. All right, so I'm having e power negative 1 multiply with negative 1 over 3. Okay, if I try to simplify, I'll have negative 1 over e power 1. Okay, therefore, we already get the exact coordinate for the m, where the x coordinate is e power negative 1 over 3, and also the y coordinate will be negative 1 over 3 power 3e power 1. Okay, so this is the coordinate for minimum point of the m, right? Okay, then we can proceed to part number B. For part number B, they want us to find the exact area. So when you see the word exact area for the shaded region, right? Basically we have to apply integration. Okay, area means area under the graph. So to find the area under the graph, we need to integrate the function. So it is bounded by the curve, x-axis, and also the line x equals to half. If you have a look for detail, okay, this is the shaded area that they want us to find. And they tell us that the area starts from x equals to half, and we need to know basically what is this x coordinate, okay, or the x-intercept. Alright, so that this is the upper limit for my integration later. I need to find out this particular point here. After that, only I start the integration. Okay, so first of all, let us go back to the question. Okay, I'm having the equation y equals to x power 3 ln x. And because I want to find out the x-intercept, right, I will let y equals to 0, where I get x power 3 ln x. And then x power 3 equals to 0. This is not the point that I want. I'm looking for ln x equals to 0 and x equals to e power 0. So when I have e power 0, the value of x should be equals to 1. Which also means that if you want to find the area of the shaded region, right? So you can see the area start from half, then end at 1. Okay, and it is bounded by the curve, which is x power 3 ln x dx. Alright, by right, it should be something like this. But if you try to observe, you will see that this area is below the x-axis. So if I integrate it by using the formula that I write out like this, I will get a negative value. Okay, and area should be a positive value always. So there are two ways that you can do it. Either you change the limit, become 1 to half. Okay, so this is one option. Another option will be you keep the limit from half to 1, but you put the modulus sign. Okay, so for your whole final answer. So that means if your final answer is a negative value, you take modulus sign and eventually you get a positive area. Right? Okay, so for me, my side here, I'm changing the limit. So I will put 1.5. Okay, so from here, you can see that this is the product of two functions again. I'm having x power 3 multiplied with ln x. And usually for the product of two different type of function, right, or the function, we might consider the integration by part. So if I try to investigate and have a look here, x power 3 belongs to algebraic function, and then the ln x basically belongs to logarithmic function. Right? If I want to apply integration by part, there's a rule that you can follow where I'm having LIATE. For the higher group of function, it will be the u. For the lower group of function, it will be the dv. And then the equation for the integration by part will be u dv equals to uv minus v du. Okay, so these are all the reference that you need to consider, okay, when you want to find out the integration by part. Okay, let me come back to our function here, right? I'm having x power 3 and ln x. So you can see x power 3 is a, which is lower, okay? And then ln x is on the higher group. Therefore, when I want to apply integration by part, I will have u equals to ln x, and the integration of dv equals to integrate x power 3 dx. Okay, so the dv here, basically, this is a value 1, right? Okay, so when u equals to ln x, right, I will want to find the differentiation for this function or this equation. So I'm having du over dx equals to 1 over x. How about integrate 1? Integrate 1, I got v. Integrate x power 3, I got x power 4 divided by 4. So this is some steps that we need to substitute into our formula later. Okay, right, so continue. Now I want to apply integration by part. The formula is u times v. So the u here, basically what I see is ln x, right? So I have ln x multiply with v. V is x power 4 over 4. Okay, so please take note that the x power 4 over 4 is not inside the ln. Basically, it should be outside the ln. Alright, so there's only the x inside the ln. If I want to rephrase it in a better way, then I will have 1 over x power 4, then ln x. Okay, then of course I have to substitute the limit inside, so I'm having half and 1. Then minus the next part of the formula is v du. So the v here again is x power 4 over 4, then du. So if I have a look from this part, if I want to have du, I will bring the dx up, then I should have 1 over x dx. Okay, so this part basically is a du. Okay, then now I try to substitute in the value, substitute the half. Okay, I'm going to substitute this half into the x power 4, then multiply with 1 over 4. Okay, I will have 1 over 64. Substitute ln x with the half, I'm having ln half. Substitute 1 into the equation here. Ln 1 is a value 0, therefore I get 0 here. Okay, then minus, for this part, I will take out the constant 1 over 4, and I can simplify x power 4 with the x, right? So eventually I'm having x power 3. Okay, then continue further. For this part, I just keep it first. I will simplify it later. For x power 3, if you integrate, you are having x power 4 over 4. Of course, don't forget about the limit of half and 1. Okay, copy the number at the first term. Then I will take out the 4, it become 1 over 16. Substitute half into the x power 4, I'm having 1 over 16 also. Substitute 1 into the x power 4, I'm having negative 1. I'm having a 1. So I minus 1, right? Okay, so from here, I will want to try and simplify the value. Okay, simplify the term here. according to the question, they want us to find the exact area, right? Okay, so how can I further simplify it? Okay, so maybe first I want to have a look for this one, ln 64, 1 over 64 ln half. I can write out or separate the ln function become ln 1 minus ln 2. Okay, it is because of we are having this rule, ln A divided by B equals to ln A minus ln B. So we are applying in this step. And then for the number at the back, I straight away press calculator and simplify them, and I will get a fraction which is 15 over 256. Okay, then if you have a look again for this particular part here, ln 1, you will get a 0. So if I try to rephrase my answer, right, the final answer that I get will be something like this. So 15 over 256, 1 over 64, multiply in with the ln 2, I'm having negative 1 over 64 ln 2. So I think this is the most simplified answer that I can get for this question, and I keep it in the exact form for the final answer. Right, so this is how we answer question number 8. Question number 9. Okay, so we are having the variable x and y that satisfy this differential equation. Then they give us the initial boundary or initial value. It is given that y equals to 0 when x equals to 0. So they want us to solve the differential equation and find the value of y when x equals to half. Okay, so for the differential equation, first of all, we try to separate the variable to two different sides. Okay, we are having e power 3y and then sine square 2x. Okay, so for me, I will want to keep the x on the right. So I'm having sine square 2x, and then I bring the dx over, right, from the left to the right. So I'm having dx here. The e power 3y, if I bring it to the left hand side, I'm having 1 over e power 3y, where I can rewrite it become e negative 3y dy. Okay, so after I separate all the variable, then I can start the integration. Okay, so integrate e power negative 3y, I will get e negative 3y divided by negative 3. Okay, you copy the original function and then you differentiate the power where you get negative 3. Therefore, you divide it by negative 3. And then for the sine square 2x here, okay, we cannot integrate the sine square 2x directly. So we have to try to think, is there any way that I can change the sine square 2x become no power 2, become something with power 1. Okay, so from here we are going to consider the double angle formula. Okay, where there's one double angle formula which involves something like this. So if let's say I'm having cos 2x, it can be written as 1 minus 2 sine square x. Okay, but for this question, because we are having sine square 2x, that means I want to change the x here become 2x, and further I want to change the double angle 2x become 4x. Okay, then if I try to rephrase this equation, right, this identity, then I'm having 2 sine square 2x equals to 1 minus cos 4x. And after that, from here, you can see very clearly that sine square 2x can be replaced as 1 minus cos 4x divided by 2. So from here, you can see originally we are having sine square with a power 2, right? The sine with power 2. And we can reduce the power, become cos power 1 by using this double angle formula. Alright, so I'm going to write it out in my step here. So I will take out the half, and then I'm having 1 minus cos 4x dx. Okay, so next step, I try to rewrite nicely for my answer on the left hand side. Half is a half. Integrate 1, I will get the x. Integrate negative cos 4x. Integrate cos, I will get sine, so sine 4x. Differentiate the 4x, I get a 4. Therefore, after my integration, I have to divide it by 4. and I'm having a term plus c at the back. Okay, then next step, try to simplify slowly. So I'm having 1 over 3e power 3y equals to half x, then minus 1 over 8 sine 4x plus c. I need to get the value for c. So to get the value for c, we are looking at the initial value given by the question. We are having y equals to 0 when x equals to 0, which means that we try to substitute the equation here. Okay, I will substitute y equals to 0. So when I'm having y equals to 0, I'm having e power 0. So e power 0 is a 1. So for the left hand side, I left only negative 1 over 3. X is 0. Okay, so this part equals to 0. Sine 4x means sine 4 times 0. Also, sine 0 is a 0. So my c basically is negative 1 over 3. Okay, so if I rewrite my equation again, then I'm having something like this. Okay, so for this question, right, they ask us another part here. They are asking for the value of y when x equals to half. By right, we already solved the differential equation at this step. So this is the solution for the differential equation. And now I want to answer the second part of the question. When x equals to half, what is the value for the y? I will let x equals to half. We try to substitute into the equation again. Okay, so I'm having 1 over 4 and then minus 1 over 8. Substitute half into the equation, then I'm having sine 2 minus 1 over 3. Okay? And then what we need to do is try to use the calculator and press the value for this one. Okay? Then divide it by negative 1. Oh, sorry. Then you bring it over left hand side, become negative 1 divided by this value. Okay, so just a small reminder. We are having sine 2 here, right? So the 2 is actually in the radian, okay, in the unit of radian. Therefore, don't forget to put your calculator into the radian mode when you want to press the answer for this, right? And then after you press the calculator, you bring the e power 3y up, 3e power 3y up. Oh, sorry, I bring only e power 3y. Okay, then I take negative 1 over 3 divided by the value on the right hand side here. Then we get the long list of value lah. So 1.69208529. Okay, to get the value of y, I need to take ln for both sides. So after you take the ln, you can bring the power in front. So ln 1.69208529. Okay, continue further by the help of calculator, right? Okay, simplify everything. You will get 0.1753206817. But of course, our answer, we won't keep it for so long, right? We will want to cut it short, correct to 3 significant figure. And the value of y should be 0.175. Okay, so this is how we answer this question number 9. Okay, question number 10. We are having the position vector for the point A, B, C, D. They want to find the obtuse angle between the vector OA and also OB. Okay, so to find the angle between two vectors, the general formula that we are using is direction P multiplied with the direction Q equals to modulus P modulus Q and then cos theta. Okay, so if you want to find the obtuse angle between the vector A and B, right? So our formula will be replaced like this. I'm having OA, okay, dot OB equals to modulus OA modulus OB and then cos theta. Now we try to substitute in all the position vector. Like OA is 3, -1, and 2. OB is 1, 2, and also -3. The modulus of OA is 3 square plus -1 square plus 2 square. And the modulus of OB should be 1 square plus 2 square plus -3 square. Then we cos theta. Okay, we try to calculate the dot product between the OA and OB. So 3 times 1 is a 3. -1 times 2 is -2. So 3 minus 2, you get a 1. Then minus 6. 3 times -2. 2 times -3 is a 6. Minus 6, right? So 1 minus 6, you get -5. So for this, I'm having -5 as the answer. Then on the right, if I try to simplify everything, I'm having square root 14 and also square root 14. Then cos theta. If we simplify from here, I will have cos theta equals to -5 over 14. And just keep the negative sign, okay, and press the answer for the angle. So the cos inverse -5 over 14, we have 110.9. Okay, so this is the obtuse angle between the position vector OA and also OB. Okay, so let's continue further. For part number B, they say the line L passes through the points AB. Find a vector equation for the line L. Okay, that means we are having a line L. It passes through A and also B. Alright, so to form the vector equation, the general formula will be R equals to A plus dB. Where the A is a passing point of the line, we are having two passing points here, right? Okay, so it is more than enough for us to find out the vector equation for this part. Then for the P here, basically it is the direction of the line. So for this particular line here that passes through AB, right? The direction of the line, we can use either A to B or B to A also can. Right, so first of all, we need to find the direction of the line first. So for me, I'm going to find out AB. AB means AO plus OB. AO will become -3, 1, and -2. And OB should be 1, 2, and -3. If we simplify from here, I'll get the value -2, 3, and also -5. Okay, so once I get a direction, which is the P here, then I can write out the vector equation for the line L. Okay, so the general formula will be R equals to A plus dP. So the coordinate for the passing point, you can use either the OA or OB, either one of them. Okay, so for me, in my case here, I'm using the B as a passing point. So I'm having 1, 2, and -3, and then plus T, the direction. So the direction we calculate just now, right, which is this value. So I'm having -2, 3, and also -5. This is my vector equation for the line F. Alright, so for your information, right, okay, for this vector equation, it is not unique now. So we are having actually a lot of different answers. For this particular part here, you also can use the other point, which is the OA, and the answer that if you use OA, then your answer might look something like this: 3, -1, and also 2. And then for this direction, if we are using the direction BA instead of AB, right, then your answer will look something like this. It will become 2, -3, and also 5. Alright, so the vector equation is not unique. Therefore, if you are having the answer different from this one, it is still acceptable. Okay, so this is the suggestion for the answer: 3, -1, 2, and also 2, -3, and 5. Okay, so the next part. For the next part, they want us to find the position vector. Okay, position vector of the point of intersection between the line L and also the line passing through C and D. Okay, so we want to find the intersection point. So before you can find the intersection point, I need the vector equation for two lines. So for the line L, I already have the vector equation earlier. And now I want to find the vector equation for CD first. So again, like what I mentioned earlier, since the line passed through C and B, let's say this is C and this is D, the direction of the line can be CD or DC also can. Right, so I'm using CD here. Okay, so CD means CO plus OD. CO is this one, -1, 2, and -5. Then plus OD, the OD should be 5, -6, and also 11. Then the direction of this line I get is 4, -4, and 6. For the direction of the vector equation, you can simplify it by factorize out the suitable number. Okay, so I will try to make the direction vector smaller. So I factorize out the 2, and therefore I get 2, -2, and also 3. Then once I have the direction already, then I can form the vector equation for the line CD. So this is for the line CD. Okay, you can use any passing point, either the C or the D in this question here. Okay, so I'm using, what am I using? I'm using the C, OC. Okay, when I use OC, I will have 1, -2, and also 5. Then plus S, then the direction is 2, -2, and also 3. And this is a vector equation for the second line. If I want to find the point of intersection, okay, I need to solve the two equations simultaneously. Okay, like according to what we learned previously, right? When we want to find the intersection point between two lines, we need to solve the two lines simultaneously to get the coordinates. So same thing happened here, right? So for the vector equation that we have just now in part A is this one. Oh, sorry, in part B is this one. Okay, so we let this equation equals to this vector equation that we have here. All right, and we try to solve it from that. Yeah. So the vector equation for line L that we get just now is 1 minus 2t, then 2 plus 3t, and also -3 minus 5t. Equals to this second line equation, I'm having 1 plus 2s, -2 minus 2s, and also 5 plus 3s. Okay, then now I can pick any of the two equations. So either you can pick this one as the first equation, and then maybe the other one is this one as the second equation, and we try to solve them simultaneously. Since we are having t and s only, right, two unknown only, so we only need two equations to solve that and to get the value for t of s. So this is the first equation. And then the second equation is 2 plus 3t equals to -2 minus 2s. And I treat this as a second equation. To solve it simultaneously, I take 1 plus 2. So on the left-hand side, I will have 3 plus t. On the right-hand side, I'm having -1. So from here, I get the value t equals to -4. Okay, so for this question, they only want us to find out the point of intersection. Therefore, I no need to continue to find the S. I need to have the value of t only, which is enough for me to find out the intersection point. So I will substitute the t equals to 4 into the vector equation of the line F. Alright, so that I can get the coordinate for the intersection point. Okay, so now since they're asking for the coordinate for the intersection point, right? Oh, sorry, they want us to find the position vector. Okay, so to find the position vector, it is anything, right? Maybe I treat it as intersection, so OP, let's say. Okay, so the position vector for the intersection point will be what? So substitute t equals -4 into the equation here, and you are having 9, then -10, and also 17. Or you can write become 9i minus 10j, then plus 17k. Right, so this is how we find out the intersection between two vectors, okay, two lines, by using vector equation. Okay, so now we are at the very last question for this paper. Okay, you are having this the function, the rational function. as shown here, and then they want us to express this function in partial fractions. Okay, so let's have a look here. Basically, you can see that the degree on top, the degree on the numerator is 2, highest power is 2, therefore the degree is 2 lah. Then when you are multiplying the x at the denominator, you are having x power 3. So the highest power x power 3, therefore the degree is equals to 3. When you are having the degree on top is less than the degree at the bottom, so basically this is a proper fraction. When you are having the proper fraction, you can straight away separate it, become the partial fractions, right? Okay, then if we have a look for the factor, the denominator, right, we are having the quadratic factor where we are having 4 plus x squared and also a linear factor. Therefore, when I want to separate into the partial fraction, this is something that we have lah. Okay, so this is originally what we have here in the question, and I want to separate it into partial fraction, right? And the first partial fraction should be with the quadratic factor where I'm having 4 plus x squared. Because this is a quadratic factor, therefore when I want to write in the numerator here, it should be 1 degree lower, which means that we should have ax plus b. Okay, because this one is x power 2, right? And then 1 degree lower means that you have to start from x power 1. So we are having ax power 1 plus b for the numerator. Then for the second part, we are having 1 plus x. Then this is a linear factor, therefore on top, it is only a constant c. Okay, multiply the whole equation by using the denominator that we have. Multiply the whole equation. The whole thing with 4 plus x squared and also 1 plus x to get rid of the denominator here. Okay, if I multiply it, I will have 5x squared plus x plus 11 on the left hand side, and then for the ax plus b, I cancel off the 4 plus x squared with the 4 plus x squared. Therefore, we are having 1 plus x for this term. For the c, you cancel off the 1 plus x and 1 plus x. Therefore, the c, we have 4 plus x squared multiplied with the c. Okay, then now we want to find all the value for a, b, and c here. So first of all, I look at this linear factor. So this is 1 plus x, right? I want to make this linear factor become 0. So if I have x plus 1 equals to 0, therefore I will let x equals to negative 1. Okay, so let x equals to negative 1. Put it into the whole equation here from the left to the right hand side. So I will have 5 minus 1 plus 11. So 5 minus 1 plus 11, I will have 15. Substitute negative 1 here, this whole bracket becomes 0, therefore ax plus b disappear. And I left this part only. So negative 1 squared is a 1 plus 4 is a 5. So we are having 5c left on the right hand side. Then from here, very easily, I can get the value for c, which is equals to 3. Okay, then the next value I want to refer to is this one. The x, I want to make the a disappear. To make the a disappear, I will want to make the x become 0. So I will let x equals to 0. Again, substitute into the whole equation. I'm having 11 on the left hand side. Then for the right hand side here, 1 plus 0 is 1. 0 times a becomes 0. I'm having b here. Alright. Then when I substitute 0 here, I'm having 4. 4 times c. c, I already get the value 3. So 4 times 3 is 12. And I will get the value for b, which is equals to negative 1. Okay, I already get the value for c and get the value for b. For the last one, to get the value for a, you can substitute because a is the last unknown that we still don't know what's the value yet, right? You can use any value for the x that we never used before. So just now we used x equals to negative 1, we use x equals to 0. So for this value, maybe I will take x equals to 1, right? Okay, so 5 plus 1 plus 11, I'm having 17. On the left hand side, x equals to 1, substitute here, I'm having a minus 1. b is negative 1, right? So a minus 1 then times what? Times 2. Alright, so I'm having a minus 1, then times 2. For this part, 1 square is still 1, so I'm having 4 plus 1, 5. Okay, 5 times 3, the value of c just now 3 is 15. And if I simplify this equation, I'll get the value a equals to 2. Alright, so from here you can see very clearly that we already get all the value for a, b, and c. Therefore, I can rewrite my fraction become partial fractions again. Okay, so this is my original rational function, right? Okay, then ax plus b. So I'm having 2x minus 1 divided by 4 plus x squared. Then plus c. c is a 3, so 3 over 1 plus x. Okay, so our partial fraction looks something like this. Okay, then now let us proceed to part number b. For part number b, they want us to show that the integration for this function should be equals to this value. Okay, alright, so for part number 1, since they ask us to separate the function fx and become the partial fraction, right? Therefore, if I want to integrate this function, I will use the result in part A, where I will straight away put in the partial fraction that I get just now. So I'm having 2x minus 1 divided by 4 plus x squared, and also 3 divided by 1 plus x. Okay, so what I want to do for this part is, first I want to separate my integration, the first term here, into two different fractions, where it will become 2x divided by 4 plus x squared, then 1 minus 4 plus x squared, and also 3 divided by 1 plus x. Okay, so the next step for the integration, for the first term here, I'm having 2x on top and 4 plus x squared at the bottom. So now let me check and see whether it belongs to f prime x over fx function or not. Okay, if I let fx equals to 4 plus x squared, which is the denominator, and I try to find out the f prime x. So f prime x should be 2x. Differentiate the 4 plus x squared, you get 2x, right? So if you try to observe the fraction that we are having here, basically we are having f prime x on top and also fx at the bottom. So that means when I want to integrate this pattern, integrate f prime x over fx pattern, generally the answer that you get should be ln fx. Okay, so for the first term, after the integration, I will have ln fx, where the fx is the denominator here, right? Therefore, after the integration, I will have ln fx, and the fx here is 4 plus x squared. I put the modular sign here because we should know that the value in the ln should be always a positive value, right? If not, you'll get a math error. Okay, so the first term that we are using, the first formula that we are using is when you want to integrate f prime x over fx, okay, then basically we are getting ln fx plus c. Okay. Alright, then next one. For the next term, 1 over 4 plus x squared. Okay, so for 1 over 4 plus x squared, right? For this integration, for this fraction, I can write it become 1 over x squared plus 2 squared. Okay, and to integrate this function, right, we should try to link it with the equation where the integration of 1 over x squared plus a squared should be equals to tangent inverse x over a, then divided by a, where I'm having 1 over a, then plus c. Okay, so this is one of the formula that you can use. We'll get tangent inverse, right? So if I write it here, then this is what we have lah. Integrate of 1 over x squared plus a squared. You should get 1 over a, and then tangent inverse x over a, then plus c. Okay, when you want to apply this formula, right, there's a small rules that you need to remember, where the coefficient of x squared should be a 1. It cannot be any other number. Alright, that only you can apply this formula to get the correct integration. Okay, so for my question here, I'm having 1 over x squared plus 2 squared, where the a is a 2. So if I integrate it, I will have 1 over 2. 1 over a means 1 over 2, right? And then tangent inverse x over a. So I'm having x over 2. Then I want to substitute the value 2 and also 0. Okay, so this is the second term, the integration for the second term. And come to the integration for third term, you're having 3, then 1 plus x. So this one is basic, where if you want to integrate 1 over ax plus b, okay, or x plus a, then basically we're having ln, then x plus a divided by the differentiation of the x plus a. So we're having 1, then plus c. Okay, this is a straightforward integration that we get along. Okay, 3 is a constant in our solution here, in our question here. So I'll take a 3 out as a constant, and I integrate 1 over 1 plus x. Therefore, I get 1 ln 1 plus x. Again, I put a modular sign because the value inside the ln should be always positive value. Okay, so after I complete the integration, then we will start substitute all the value here. So substitute 2 into the equation here. I'm having 2 squared is a 4, then I'm having ln 8. Substitute 0, I'm having minus ln 4. Okay, for the second term, substitute 2, I'm having tangent inverse 1. And then if I substitute 0, then I'm having tangent inverse 0. Okay, last term, substitute 2, I'm having ln 3. Substitute 0, I'm having ln 1. Okay, ln 8 divided, ln 8 minus ln 4, I can combine them, become ln 8 over 4, where I'm using the properties of the ln function, where if I'm having ln a minus ln b, it can be written as ln a over b, or the other way around. So I'm applying this on ln 8 minus ln 4. Okay, tangent inverse 1, if you press calculator, put it in the radian mode, right? Put it in the radian mode, and then tangent inverse 1 will give you the value pi over 4. For those who are using MS calculator, then maybe you have to draw the triangle, the right angle triangle, to help you and get the value for tangent inverse 1. Okay, maybe in the radian unit, right? Okay, so I will have minus half and then pi over 4. For the value of tangent inverse 0, right, I'll get a 0. Okay, then for the last term, 3 ln 3, I will have ln 3 power 3, which is ln 27. Okay, so this one I have ln 3 power 3. I bring the 3 over, go back to become the power. So 3 power 3 is 27. I'm having ln 27. Then minus ln 1. Ln 1 is basically a 0. Okay, so I'm having minus 0 or plus 0 at the last value here. Okay, then what else can I combine? I can still combine this ln and this ln. So we are having plus, right? Ln a plus ln b. So if I'm having ln a plus ln b, you can also simplify it by multiplying a and b together. I'm having 8 over 4, which is a 2, and then 27. So ln 2 plus ln 27, that means I'm having ln 54. 2 times 27 is 54. And then simplify this term, I'm having 1 over 8 pi. And you can see that this is the answer that they want us to show. Okay, right. Yeah, so we have finished discussing all the questions in this paper, and thank you very much for watching this video.